So now we're going to find a power series with c equals 0 for the function f of x equals 1 over 1 minus 2x, and let's say where that power series converges. So let's, all right, so the thing to recognize here is that we're always trying to get we're always trying to get an expression like this into the form 1 over 1 minus something. And then that's going to equal the sum from n equals 0 to infinity of whatever that something is to the n. That's sort of how we're using what we know about geometric series and their sum in order to construct this type of power series for a function. So in this case, the thing in the box is just the 2x. So the correct answer here is going to be that f of x is equal to the sum from n equals 0 to infinity of 2x to the n. And you can write it that way. Many people do. I always like to, when it's I like to take the x to the n term out. So this is going to be n equals 0 to infinity of 2 to the n x to the n. And this, of course, is going to converge for any time this thing, which is standing in for the common ratio, is going to have to be absolute value of 2x is going to have to be less than 1. So in other words, for the absolute value of x is less than 1 half. And of course, since it's a geometric series, we know that it does not converge at the endpoints. It does not converge when the common ratio is equal to positive or negative 1. So we can actually state what the interval of convergence is here. It's just going to be negative 1 half, 1 half. You could say it either way. You could say that it converges for that condition, or you could say it converges in that interval. Either of those would be correct. And of course, this is the power series for the function. What does this actually mean? What this means is that as long as we're in this interval, keep in mind this function f is defined for a lot of values that are not in this interval. I could put in x equals a million and get a value. This series does not work for values of x equals a million. But for this limited range of values, this function is equal to the sum of this series. So, so if I wanted to know, for example, what is f of 1/4, that would equal 1 over 1 minus 2 times 1/4, which is 1 half. So that's going to be 1 over 1 half, which is 2. That would also be equal to the sum from n equals 0 to infinity of 2 to the n times 1/4 to the n, which when we simplify it just comes out to, is just going to come out to 1 half to the n. So the point is that this is going to equal this. They are the same calculation as long as we stay within this interval of convergence. The series stands in for the function. We're going to see later why that's important. But basically, sometimes it's more convenient, believe it or not, to use the series or a little piece of the series as a replacement for the function itself.